Well, like the old song from the 80s, the Olivia Newton-John song says, "Let's get physical." This is Network Plus, cables and connectors. And in this particular series, we're going to look at four main topics. First of all, we're going to break down the properties of cables, some of the things that are properties or attributes that will apply across all the different cable types, like things like transmission speeds, distance, duplex, immunity to noise, frequency, things like that. Then we're going to look at specific cable types and properties of those cable types, specifically the ones, of course, that are covered on the Network Plus exam. There are literally thousands of different cable types out there in the electrical world and the cabling networking world, but we're going to focus on the most important ones, things like category 3 through 6, STP, UTP cable, fiber, coaxial, things like that. Then we'll look at some wiring options like straight through cables versus crossover cables. And then finally, we'll look at the most common connector types. Things like RJ11, RJ45, BNC, RS232 for serial cabling. Then we'll look at some fiber cabling, SC, ST, and LC. Sound good? Okay, let's jump into it. Now, before we dive in and look at all these many different types of cabling and properties and connectors and all that, let's get the big picture here. We know that there's all different types of cabling in the world. I mean, for heaven's sakes, there's cabling that holds up suspension bridges. We're not talking about that type of cabling. We're talking about structured cabling, building or campus telecommunications cabling infrastructure. Structured cabling falls into several categories. We're going to be focusing on work area components, connecting end-user equipment to the outlets of the horizontal cabling system, which is connecting telecommunications rooms to individual areas of the building or the floors. So we're focusing mostly on local area networking and, to some degree, wide area networking cabling as well. The kind of cabling standards that go into wiring data centers and offices, a data center like the one you're looking at here, apartment buildings, all different environments. Now, there's different properties to cables. One of these properties happens to be transmission speed. Now, there's properties beyond that, of course. You've got impedance and propagation delay and inductance and things like that that really adhere to the physical aspect, but we're going to focus on the ones that affect us as networking professionals. First of all, cables are rated for maximum transmission speed, so they can handle speeds, let's say, of 1 megabit per second to 2 megabit per second, 10 megabit. We've had 4 and 16 and 100 megabit per second. That's fast Ethernet. 1,000 meg per second is gigabit Ethernet, and we have 10 gig and beyond. When you move from regular Ethernet cable, which we'll look at here, UTP cable, to fiber optic cables, we get much faster transmission speed. So one of the things that defines cabling is the property of the ability to move data on that particular medium. Another thing that dictates cable properties is frequency. Frequency is the number of occurrences of a repeating event per unit time. So it's oscillations or waves or cycles. And we measure frequency in hertz. So just for an example, we're going to look at category 5 cabling here. Category 5 unshielded twisted pair that is rated for frequencies up to 100 megahertz, and all cabling have their own frequency ratings. Distance is another thing. Cables are limited to a maximum distance. Once that distance is reached, then the signal starts to degrade or break down. So for example, if we look at category 5E cable, which is a newer version of 5, a very popular version, category 5E cable can have a distance of up to 100 meters or 328 feet. And one of the main reasons for using hubs and repeaters that we'll talk about later on in the series was to extend the capabilities, the physical capabilities of these cables that we use that typically couldn't go beyond 100 meters. Now, most of our cabling that we deal with now are patch cables, and patch cables are, 1 foot, 3 feet, 10 feet, and so on. Then we have what's called duplex. Our networking cables are used for at least half duplex communication. Now, duplex simply means a system where you have two devices or two connected parties in each direction. So, it's not using a megaphone, for example. That's not duplex communication. A loudspeaker is not duplex. So what we have is what's called half duplex and full duplex. So half duplex is basically a system where you have communication in two directions, but only one direction at a time, okay, not simultaneously. So a great illustration of half duplex would be walkie-talkies, for example, okay, where you're talking to your friend and you have to hold down the jack and start talking, and when you're done you say over and you disengage and then they can start talking. Or a CB radio, citizen band radio, is a half duplex communication. Full duplex, which is what we deal with most often now in modern networking, or double duplex, allows communication in both directions. When you, for example, plug your workstation into a switch port, that's full duplex communication. This would be telephones, mobile phones. As we're going to see in this nugget, full duplex Ethernet connections work by making simultaneous use of two physical pairs of twisted cable which are inside of the cable jacket, where one pair is used for receiving packets and one pair is used for sending packets. So you have two pairs per direction, and even two pairs per direction for some types of Ethernet, okay, going between devices. So we want to understand the concepts of half duplex and full duplex. And then there's immunity to noise, okay? Electromagnetic interference. Some cables are more susceptible to EMI and actual security of capturing information off that media than other types. And we'll talk about that. So each of these different cabling types has their own noise immunity properties as well. Some are more immune than others. Fiber optic cables, for example, are way more protective to interference and EMI than would be unshielded twisted pair cable, for example. Let's go ahead and take a look now at some specific types of cabling, standard cable types and their properties. Let's start with category 3 cable because it's probably the oldest cable you're going to find out there, and it's got some of the properties you want to talk about. The first of the properties is what's called twisted pair. The twisted pair is made up of insulated copper wires that have been twisted around each other, as you can see here, and they form wire pairs. The wire is typically 22 to 26 gauge, with more than one pair being carried in a single jacket or a sheath. So you can see here we've got the yellow sheath here and a gray sheath here. And now, because wire carrying electricity transmits and receives electromagnetic energy, nearby pairs of other wires carrying signals can also interfere with them. So this is called crosstalk. So to reduce crosstalk and other sources of electromagnetic interference, EMI, we twist these wires. Now, the number of twists and the interim spacing are specified by industry standards organizations like the IEEE, for example. Standard commercial grade cable supports 2 twists for every 11 inches. So cables that have a greater number of twists within that 11-inch measurement can actually support data transmissions at higher speeds and greater distances. Now, twisted pair cabling is divided into 2 categories: UTP, unshielded twisted pair, and STP, shielded twisted pair. Now, category 3 cable that we're looking at here is an unshielded twisted pair cable. UTP is a set of twisted pairs in a plastic sheath, and this is common for telephone wiring and local area network communication. It can carry data reliably up to 10 megabits per second with possible bandwidth of 16 megahertz. It's part of a family of copper cabling standards defined by the EIA, the Electronic Industries Alliance, and TIA, Telecommunications Industry Association. As a matter of fact, later on I'll show you, for example, some serial cabling, and it's actually defined as EIA, TIA with some number following it. Category 3 was popular in computer networks in the 90s, but it's fallen out of popularity because of the Category 5 or the Cat 5 standard. What you can see here is a comparison of the Cat 3 cable to the Cat 5 cable. The reason why we don't really see Category 3 anymore is because most networks are not 10 megabit Ethernet networks anymore. Most of them are moving up to the fast Ethernet, or 100 megabit per second at 100 megahertz. So we don't see Category 3 much anymore. Let's talk about Category 5, which is the ubiquitous standard. Now here's the three main types of category cable that we see nowadays: Category 5, 5E, and 6. Now let me just tell you, on the Network Plus exam by CompTIA, they're still going to test you on technologies that are actually no longer officially recognized. For example, Category 5 cable is currently not recognized by the TIA EIA. As a matter of fact, there's two different types of wiring for Category 5, TIA EIA 568A and 568B. I'll show you that here in a second. Only 568A is recognized. However, the CompTIA Network Plus exam may still test you on Category 5 cable and 568A. Unfortunate, but just happens to be the case. Now, Category 5 cable here is a twisted pair, so you got 4 twisted pairs. It used the wiring known as EIA 568A. I'll show you that wiring here in a second. So you want to know that Category 5 uses 568A. Category 5E uses the wiring 568B. Category 5E is an enhanced version of Category 5 that adds specifications for far-end crosstalk. And again, this is the new enhanced version, so the TIA EIA no longer really recognizes Category 5 anymore. If you go to the store to buy Cat 5 cable, you're going to get Cat 5E. Now notice I haven't even talked about connectors yet. Obviously all these cables, they typically have connectors. Can you take the wires into a patch panel and kind of wire them up that way? Sure, and that's still done. I'm not even talking about connectors yet until really it's time to talk about connectors, because we don't really want to confuse things. Now with Category 5E cable, you're still limited to 100 meters or 328 feet. It gets performance up to 100 megahertz, and it can be used for 100 megabit. I guess 100 is the key number here. 100 megabit per second networks, or what we call fast Ethernet, but also supports gigabit Ethernets, which is 1000 megabit per second, or 1 gigabit. Now, Category 6 cable also uses the 568B wiring, which I'll show you here in a second. It has performance up to 250 megahertz, which is more than double the Category 5 and 5E. This can be used in gigabit networks, and actually there's already a Category 6A and soon a Category 7, which is going to get you obviously operating at 500 megahertz and 600 megahertz respectively, and suitable for 10 gigabit networks and beyond. So these are the main Category 5 Ethernet cables that we run into nowadays. So here's a side view of our UTP cable, say Category 5, 5E, and 6. Here's our plastic sheath. We've got these color-coded wires with the copper wire inside of it. Here's a cross section, and now the 568A wiring, this was for Cat 5. Okay, for 568B, this is Cat 5E and Cat 6. So what you've got here, don't worry about this jacket information and ripcord and conductor and all that. This is obviously the jacket, this is the sheath of the jacket. There's a conductor, which is the copper wire, and then the insulation, which is color-coded. So you can see over here in our 568B wiring, which is really the most important one to memorize because it's the one that's recognized, is you've got the orange wire, with the white and orange. You've got the blue wire with the white and green. You've got the green wire with the white and blue, and you've got the brown wire with the white and brown. So, and these are the pin numbers right here. So these would coordinate to where you place these in the connector, which will typically be an RJ45 connector, which we'll show you a little bit later on when we get into connectors. I don't want to get you mixed up here, but these wire numbers are going to relate to the positions, the pin positions, where you place those 8 wires as you connect them into the connector, both the female side of the connector, the jack, and the male side. Now let me give you kind of a common example of kind of the big picture of a UTP installation in a local area network. So here's your workstation or your laptop in your cubicle, for example, and you've got a Ethernet card here, and you have an Ethernet card here, and this is going to be your category 5E or category 6 patch cable, 3 foot, 7 foot, 10 foot. This is going to go into the wall jacks. You're going to have an RJ45 connector on the end of this category 5E cable that's male that connects into this female wall jack. And then, of course, the female has the wires set into it based on the numbering I showed you earlier, the 568B and the pin numbers 1 through 8. And this drop cable here is going to be probably going in a cable run in a wide variety of different ways. And then it may go into a 66 block where the other end of this end of this cable right here is just going to have the raw wires that get punched into the block. And then this cable has the wires punched into the block. This comes to a cable to a patch panel. This patch panel is kind of a repeater, and the patch panel matches up. So these would be labeled on the patch panel, where, what area this is in, what cubicle number or whatever. And then the patch panel comes in and then back into this switch right here. This could be a layer 2 or a layer 3 switch. Now, you could bypass the 66 block altogether and just have the drop cable come to the patch panel, and then the patch panel come into your switch. Or in a small organization, you literally could have the drop cable coming to a departmental switch, a layer 2 switch that's connecting different departments. But typically you have a patch panel in a rack, and it goes into the layer 2 or layer 3 switch. That's a typical configuration using category 5E and category 6 cabling. And again, all of those 568B color codings and pin numbers all come into play here as you set these wires into the block and as you connect into the patch panel. Because a lot of organizations, they don't go out and buy retail cable. You have to do your own cabling. You'll just sit there for hours and hours and cut and crimp and wire and create your own cabling structure, because it's so much more expensive to go out and buy retail cable from your local retailer. Coaxial cable is used in older Ethernet environments, cable TV, ArcNet implementations, and it's composed of 2 conductors that share the same axis. The center cable is insulated by plastic foam, so you can see here's our copper wire here and the foam insulator. Then you'll find a second conductor, which is this copper mesh here. There might be a foil wrap like you can see on this RG6 kind here, and then the external plastic tube with the outside insulation. Now, for proper functioning, coaxial cable has to always be terminated at both ends, and the outer conductor grounded at only one end. Termination is achieved by connecting the inner conductor to the outer conductor by using a resistor of a certain size. Many terminators have a grounding wire which can be connected to an earth ground, like a water pipe, for example. Now, the size of the terminating resistor is measured in ohms, like 50 ohms or 75 ohms or 93 ohms. And by connecting the inner and outer conductors with the terminator, you complete the circuit for electrical signals to flow in the cable. If one or both ends of the cable aren't terminated, there's no electrical circuit and therefore no data communication. Some things about coaxial cabling: it's got a moderate cost compared to other media. It's kind of clumsy to install for individual workstations, so you don't really see it much anymore. Its capacity has transfer rates of 1 to 100 megabit per second, with 10 megabit per second being the common rate for LAN environments. And since most LANs are moving beyond 10 megabit per second, you're not going to see coaxial in LANs very much anymore. It has some sensitivity to electromagnetic interference as well. The two main conductors that CompTIA wants you to know about are the RG6 and the RG59 coaxial types. The two main types of coax cable that the CompTIA wants you to know about are the RG6 and the RG59. The most commonly recognized variety of RG6 coax is your cable television distribution coax that you've seen in your home or your apartment. They've become the standard, and they've replaced the smaller RG59 that you can see here in the upper right hand corner. There are other types, but RG6 and RG59 are all you really need to be worried about. Shielded twisted pair has a lot of the same characteristics of unshielded twisted pair, but it includes a protective sheathing around the copper wire. The twisted pair is wrapped in foil to cut down on outside interference and electromagnetic radiation. It's designed for a 22 gauge wire, which has a thicker wire core and supports longer distances than the 24 gauge variety. Some things about STP. It has a moderate cost. The shield in STP has to be grounded, making insulation more difficult than unshielded twisted pair. So special connectors and installation techniques are necessary. With the reduction of external interference, greater transmission speeds up to 500 megabit per second are common implementations. Distance is still limited to 100 meters, and STP is more protective against interference, crosstalk, and EMI emissions, but it can still suffer from outside interference. STP is nowhere nearly as widely implemented in local area networks as UTP is. Let's talk about fiber, starting with multi-mode optical fiber. This is a form of optical fiber that's used for shorter distance and data communication. It's becoming much more popular in local area networks, or you can see it between buildings or on a campus or even a metropolitan area network. Typical multi-mode links are going to have data rates of 10 megabit per second all the way up to 10 gigabits per second. So obviously fiber gives us that faster transmission speed, with links of up to 600 meters. So you can see here the advantages over traditional Ethernet cabling. The equipment used for multi-mode optical fiber is less expensive than the other version we're going to look at here, single-mode optical fiber. And MMF has different types of connectors that we'll look at here a little bit later on. Single-mode optical fiber, as opposed to multi-mode, is designed to transmit only a single ray of light. So that's why it's called single-mode. This ray of light often has a variety of different wavelengths. Single-mode fibers, because of the science behind it, are better at retaining the fidelity of each light pulse over long distances than are multi-mode fibers. So single-mode fibers can have higher bandwidth than multi-mode fiber, but the equipment for single-mode fiber is far more expensive than the multi-mode optical fiber equipment, but ironically, the single-mode fiber bought in bulk is actually cheaper. As you can see here on the left-hand side, we have a diagram for the way the single-mode fiber is built. Looks kind of like coax, but the core is actually a single ray of light. On the right-hand side, we see some single-mode fiber cable. Another thing to understand about cabling is that some cabling can be plenum cable and some can be non-plenum. Plenum cable is the cable that's laid into the plenum spaces in buildings. This is an area that facilitates circulation for heating and air conditioning systems. This is a space between the structural ceiling and the dropped ceiling. For example, here's our building, here's our furniture down here, here's the dropped ceiling. As the forced air supply comes in, the heating and AC comes in, here's the forced air return. This is the plenum space. The plenum space is often used to house communication cables for the computer network and telephone network. So we've got certain cabling that's rated to be placed in the plenum space and cabling that's not able to be put in the plenum space. And it's often hard to tell just from looking at the cable. For example, up here we have some category 5 and category 6 plenum cable, and down here we have some category 6 and coax non-plenum cable. So the important thing here is that knowing if you're going to run cable into that plenum area, you have to make sure that the cable is rated as plenum, and if it's not, you don't want to place non-plenum cable into that area up there above the dropped ceiling or even under a raised floor. A raised floor is also considered plenum as well. Next, we want to discuss straight-through cables and crossover cables and loopback cables. Now, this isn't really a type of cable. It's just really the way that the wires are going to interface with the particular connector. For example, here's a category 5, 568A, and you can see the RJ45 plug. And obviously, we're going to insert these wires 1 through 8 into pin 1 through 8. Now, a straight-through cable simply means this. The pins on one end correspond exactly to the corresponding pins on the other end. Pin 1 to pin 1, pin 2 to pin 2, and so on. So you'll use the same wiring at each end on a straight-through cable. Straight-through cables are commonly patch cables. They go from a PC or a laptop to a hub or a switch. They'll also connect to that port in your cubicle. It can be from your PC or your server to a residential router or gateway, because those ports have the crossover capability built into them. A wireless access point to a hub or a switch will also use a straight-through cable. And when you go to buy these retail, it should tell you on the cable if it's a crossover cable or not. Let's talk about a crossover cable, which is much more complex. Now, a crossover cable is typically a patch cable that's used to connect similar devices, like a hub to a hub, or a router to a router, a server to server, PC to PC, laptop to PC. It can even be a computer to an uplink port on a hub or a switch. So in a crossover cable, the pins don't correspond like they do in a straight-through cable. So we're going to swap some of the cables. Now, you don't have to worry about this if you go to the store and just buy a crossover cable. It's already done for you. But chances are, as a network professional, you'll have to do this on your own. So in other words, if pin 1 on one end goes to pin 2 on the other end, then pin 2 on the first end goes to pin 1 on the second end. So you have to understand, for example, the Ethernet crossover cable, which basically converts between a T568A and a T568B termination. So we need to memorize this for the exam. And here's a prime example right here. And you can see we've got these 4 wires that are used. We have a transmit positive, transmit negative, receive positive, and receive negative. So instead of having a 1-to-1 relationship, you can see that transmit 1 here is going to cross over to receive 3. Transmit 2 here is going to cross over to receive 6. Receive 3 on this end is going to cross over to transmit 1. 4 and 5 stay the same. Receive 6 crosses over to transmit 2 on this end. 7 and 8 stay the same. So you need to memorize this for your CompTIA exam. Okay, the rollover cable is actually kind of a proprietary Cisco console cable. It's the cable that connects from your management station or your management PC to the console port on the back side of a Cisco networking device. It doesn't have to be Cisco, but it usually is Cisco. And you can see over here we have this special adapter which kind of connects to this cable here. This is going to go into the serial port on your laptop or your workstation, and there'll be a console port that accepts this jack on the router or the switch or the PIX firewall or the IPS sensor, whatever it is that you're configuring through a console session. And you can see with the rollover cable here, this just shows you that this is basically all the cables and the pins are rolling over from one side to the other. So everything kind of gets flipped over when it gets to the other side of the connection. It's Typically a flat cable like this one, a light blue flat cable, even though I have some newer ones that are thin dark blue cables. And again, you get the name rollover because the pinouts on one end are reversed from the other end, like the wire's been rolled over as you were viewing it from the other side. The rollover cable is also commonly known as the Yoast cable, Y-O-S-T. Finally, we're going to talk about connectors, and I want to separate this whole discussion because you may be using category 5E cable or category 6 cable, and you could still use an RJ11 pin or a RJ25 pin or RJ45 pin. So we want to make sure we have the connectors broken down by themselves. So we're going to look at these 7 different connector types as demanded by the Network Plus objectives. First is RJ11. You can see the RJ11 connectors. These are the ones you typically see in your going to your telephone. The one that goes into your telephone jack on the wall, or the one that you plug from your telephone into a modem, for example. You can see here's the male side of the RJ11 connector, and here's the female side right here that would connect in. And then this is the actual pin out. Now, cables sold as RJ11 are typically always what we call 6P4C. 6 positions, 4 conductors. So you can see here we've got 6 positions, and we've got the 4 conductors: the black wire, the red wire, the green wire, and the yellow wire. The RJ45 cable is the one you're probably most typically familiar with. It's used to terminate twisted pair cable. On the plug, you've got conductors that are flat contact, positioned parallel with the connector body. These RJ45 jacks have actually replaced the older connector types like BNC connectors that we're going to talk about next. As we talked about, from a wiring standpoint, RJ45 jacks are frequently terminated using the T568A, or nowadays the T568 pin pair assignments in category 5E and category 6 cable. Here you can see a male RJ45 connector, the female part of this, which could be what you plug into in a data port in your cubicle, for example. And then here are the pin configurations in the RJ45 connector. The BNC connector, or the bayonet Neil-Conselman connector, is a very common RF or radio frequency signal connector typically used for terminating coaxial cable. It's used for a wide variety of connections, for analog and SDI video signals, amateur radio. BNC connectors used to be used commonly on 10-base-2 thin Ethernet networks, both on the cable interconnections and the network cards. These have pretty much been replaced by newer Ethernet devices and cabling that's not using coaxial cable, and some ArcNet networks use BNC terminated coax. The SC connector is an optical fiber connector that terminates the end of an optical fiber cable. It allows a lot quicker connection and disconnection than actually trying to splice the cable. The connectors mechanically couple and align the cores of the fibers so that light can pass through. Now actually, in datacom and telecom applications, these small form factor connectors like LC that we're going to look at here in a second are replacing these traditional SC connectors, mainly because you can pack more connectors on the overcrowded faceplate. But still, the SC connector is extremely common in your datacom and telecom fiber network. SC stands for subscriber connector or standard connector, or sometimes Seimon, S-E-I-M-O-N connector. Another optical fiber connector is the ST connector, which stands for straight tip. It's also referred to as a BFOC, bayonet fiber optic connector, and you see this almost always used in multi-mode fiber. Rarely is it used in single mode. But since multi-mode is so popular and so widely used for short distances, you'll see ST connectors used quite a bit. The LC connector is a small form factor connector, which is rapidly replacing the traditional connectors like SC. As you can see here, you can get more connectors onto the faceplate. The LC in LC connector stands for lucent connector, or it's also referred to as local connector. It snaps on, and it's used for high density fiber connections. Finally, we have the RS-232, or Recommended Standard 232 serial connector, which is extremely common throughout the entire telecommunications industry. It's a serial cabling connector standard for connecting between a DTE, a data terminal equipment, and a DCE, data circuit terminating equipment. These are extremely popular, for example, in the Cisco world. An RS-232 connector needs to be identified as either the DTE side or the DCE side. There are several different pin assignments. You don't need to worry about those, but the two most common connectors that we see in the RS-232 standard are the DB25S, which of course has obviously 25 pins, and you can see it right here. Here's a common example of the DB25S down here. The male and the female, the DCE and DTE side. The male can be DCE or DTE. It just depends on the cable. Here's the DB9, which has 9 connectors on it. This is also part of the RS-232 series. And besides the type of signals that we saw on the other cables, like the transmit data, the receive data, there's also other pins that are used for things like request to send signaling, ready to receive signaling, clear to send receiving, data terminal ready, all these types of things that are used in serial communications. And speaking of serial communications, and by the way, serial just means that the zeros and ones are lined up in a serial fashion and sent one at a time on the wire. And you can see here just one example of, here's a Cisco cabling, a DCE DTE cable that's using the EIA TIA 232 standard. But you can also see that for serial cabling, Cisco has several other standards they adhere to as well. V35, X21, EIA 530, EIA TIA 449. So the RS-232 is just one of many serial connection standards that are out there that are used. Alrighty, this was a long one, but in this CBT Nugget of the Network Plus series on cables and connectors, we covered 4 areas: cabling properties, cable types and properties, wiring options, and common connector types. I hope this CBT Nugget has been informative for you. I want to thank you for viewing. See you next time.